Mr. Prasoon Bandyopadhyay. He's an architect with 6 years of experience in IT parks, institutional spaces and retail design. He graduated in the year 2011 from National Institute of Technology, Patna. He joined L&T Construction in 2011 and worked in various multi-million projects spanning from various IT parks to institutional spaces. Presently, he serves as a lead architect at Future Research Design Company.
Welcome to UGC lecture series. This is AR 6013 Construction Technology. This is lecture number 4. We will be talking about unit 2, that is construction practice. So, what are we learning today? We are learning about precast concrete elements, their manufacture, their preparation and storage, molds, accelerated hardening property of them, curing, stacking during transport and storage, handling arrangements, identification and marking, transport, erection and equipments. And in the next part, we will be learning about safety in dismantling. First of all, we will talk about the precast concrete elements. How are they manufactured? The manufacture of the components can be done in a factory for the commercial production established at the focal point based on the market potential, or in a site precasting yard set up or near the site of work. So, what are precast concrete elements? First of all, the precast concrete elements are something we have learnt about concrete earlier. So, precast, there are two types of preparation of concrete elements. One is on-site preparation and the second is it can be manufactured. Parts of elements, the elements of concrete can be manufactured in a factory, in a yard, and it can be brought to the site and it can be fixed like building blocks on the site. So, we will talk about it now in the due course of the lecture, and also we will learn how these precast concrete elements, what are the properties of precast concrete elements, how are they created, how are they created on site, how are they created off site, how are they lifted, how are they transported to the site, and how to create the molds and how to put together to form beautiful structures. So, first of all, we will talk about factory prefabrication. Factory prefabrication is resorted to in a factory for the commercial production for the manufacture of standardized components on a long term basis. We most often use standardized components for example, bridge constructions, for example, girders, for example, even columns, parts of columns, for other structural materials, for shear walls, etc. We use precast concrete elements in the construction industry. We use prefabrication of concrete in the construction industry for many components, and it has a variety and very important uses. It is a capital intensive production. Prefabrication of concrete is a capital intensive production where work is done throughout the year, preferably under a closed shed to avoid effects of seasonal variation. High level of mechanization can always be introduced in the system, where the work can be organized in a factory like manner with the help of a constant team of workmen. Another part is site prefabrication. In this scheme, prefabricated components are produced at site or near the site of work as possible. Under this category, there are two types, that is semi-mechanized and fully mechanized. Now, semi-mechanized mode works are normally carried out in open space with locally available labor force. The equipment machinery used may be minor in nature and the molds are of mobile or stationary in nature. Fully mechanized. The work carried out under the shed, this work is carried out under the shed with skilled labor. The equipments used are similar to the one for the factory production, and this type of precast yards will be set up for the production of precast components of high and precise quality, and this would also have high rate of production. The various processes involved in the manufacture of precast elements are classified and listed as below. The main process: providing and assembling the molds, placing reinforcement cage in position for reinforced concrete work, and stressing the wires in the case of pre-stressed elements. The second is putting concealed service conduits or pipes. Third is fixing of inserts and tubes wherever necessary for handling. Fourth, pouring the concrete into the molds. Fifth, vibrating the concrete and finishing. Sixth, curing. The curing can be done, steam curing can be done if necessary. And seventh point is demolding the forms and stacking the precast products. Another process is auxiliary process. Process such as the following as listed below, necessary for the successful completion of the processes covered by the main processes. First is mixing and manufacture of fresh concrete done in a mixing station or by a batching plant. Second is prefabrication of reinforcement cage, that is done in a steel yard or a workshop. Third point is manufacture of inserts and other finishing items to be incorporated into the main precast product. And fourth point is finishing the precast products. And fifth point is of course testing of the product. There is a process called subsidiary process. All other works which are listed below are involved in keeping the main production work to a cyclic working. For example, number 1, storage of materials. Number 2, transportation of cement and aggregates. For the transportation of raw materials is important. Number 3, transportation of green concrete and reinforcement cages. Number 4, transporting and stacking the precast elements. Number 5, repairs and maintenance of tools, tackles and machines, very important. Number 6, repair and maintenance of molds. Number 7, maintenance of curing yards. And number 8, generation of steam, etc. For the manufacture of precast elements, all these processes shall be planned in a systematic way to achieve the following. Number 1, a cyclic technological method of working to bring in speed and economy in manufacture. Number 2, mechanization of the process to increase productivity and to improve quality. The optimum production satisfying the quality control requirements and to keep up the expected speed of construction aimed. Next point, better working condition for the people on the job, and last but not the least, minimizing the effects of weather on the manufacturing schedule. Another, precast concrete elements are very important in the construction industry. For one important thing that I want to add it right now is the precast concrete elements. With the use of precast concrete elements, the construction is super fast, because we don't have to rely on the site conditions, we don't have to rely on manpower at the site. The mistakes that are made by men at the site, because the manufacturing process is mechanized, and so there is no room for any error. And it is a very quality product, it is a very finished product, and there are no deviations. Two components are exactly alike and there are no deviation from each other. So if you can see the table here, the various stages of manufacture of precast concrete elements are elaborated here in this table. If you see here, these are the serial number. These are the precasting stages, the various stages one by one after the other. These are the names of processes and these are the operations involved. I'll briefly take you through this table. First stage is procurement and storage of construction materials. The operations involved, of course, are unloading and transportation of concrete, coats and aggregates and steel, and storing them in bins, silos or storage sheds, etc. Second stage is testing of materials, testing of all materials including steel. Third is design of concrete mix, that is testing of raw materials, plotting of grading curves and trial of mixes in the laboratory. Fourth is making of reinforcement cages, unloading of reinforcement bars from wagons or lorries and stacking them in the steel yard, cutting, bending, tying or welding the reinforcement and making in the form of a cage which can be directly introduced into the mold. Fifth stage is applying form release agent and laying of molds in position. Molds are cleaned, applied with form release agent and assembled and placed at the right place. Sixth stage is placing of reinforcement cages, inserts and fixtures. The reinforcement cages are placed in the molds with spacers, etc. as per data sheet prepared for the particular prefabricate. Preparation of green concrete is the seventh stage. Taking out aggregates and cement from bins, silos, etc., patching and mixing. 8th point is transportation of green concrete. Now the green concrete that we now prepared has to be transported from the mixer to the molds. In the case of precast method involving direct transfer of concrete from mixer to the mold or a concrete hamper attached to the mold, this fabrication stage is not necessary. 9th stage is pouring and consolidation of concrete. Concrete is poured and then vibrated to achieve a good finish. 10th is curing of concrete and demolding. Either a natural curing with water or an accelerated curing using steam curing and other techniques can be done. In the case of steam curing using trenches or autoclaves, this stage involves transport of molds with green concrete into the trench or autoclave and taking them after the curing and demolding elements. Now after that, cutting of protruding wires also falls in this stage. In certain cases the molds have to be partly removed and inserts have to be removed after the initial set. The total demolding is done after a certain period and the components are then allowed to be cured. So all these fall in this operation. The 11th stage is stacking of precast elements together. Now lifting of precast elements from the mold and transporting to the stacking yard for further transport by trailer or rail is part of the stage. Testing of finished components. Now tests are important part because without testing we cannot use it for structural uses. So tests are carried out on the components individually and in combination to ensure the adequacy of their strength. Now there are miscellaneous stages also. For example, generation of steam involves storing of coal or oil which are necessary for steam generation. Now second is repair of machines used in the production. So these are the various stages and including miscellaneous activities which are done to produce precast concrete elements. I would like to take you through this figure, that is the planned process used for the manufacturing of precast concrete elements. Now if you see here, there is water, there is fine aggregate, there is coarse aggregate and there is cement. All these are measured, mixed and they are put together in a mixture. Then there is mild steel and there is wires, high tension wires. So these are cut, these are bended and these are binded together. Then the high tension wires are threaded, these are stressed, they are binded together and then the molds are put together. So in this case what happens, we have the molds, we have the concrete and then we have the cage that are made up of steel wires, mild steel bars put together in the shape of the form we want to put concrete into. So now what we do is, we put the mold, we take the mold, we put all this together and then we fill concrete inside. So now happens compacting, then the next step happens curing and detensioning, then happens demolding. Now one important step, critical step is how these molds are formed. First of all, the formation of molds also can be done in a prefabricated way. The molds are basically made up of steel or molds can also be made up of wood. So in these molds can be reused, at till different processes. These molds can be used and reused, and these can be again used for the formation of precast concrete elements. So here you see, once it is demolded, it is cleaned, it is fitted if there is any damage to the mold, and then it is again oiled and put to the use for another precast element. And then the concrete that is coming out after demolding is cured in the yard, and then it is tested and dispatched by road or by rail. So these are, in a flowchart way, all the activities that are required for manufacturing the precast elements. So the second point, we get the precast elements from the yard. So now how would be prepared and where would it be stored? The storage of materials is of considerable importance in the precasting industry. From experience in construction, it is clear that there will be very high percentages of loss of materials as well as poor quality due to improper storage and transport. So in a precast factory where everything is produced with special emphasis on quality, proper storage and preservation of building materials, especially cement, coarse and fine aggregates, is of prime importance. Storage of materials shall be done in accordance with IS standard 4082. Now molds. As I described earlier briefly, now we will go through it properly. The molds for the manufacture of precast elements may be of steel, timber, concrete and plastic, or a combination of all of these. For the design of molds for the various elements, special importance should be given to easy demolding and assembly of the various parts. At the same time, rigidity, strength and water tightness of the mold is an important part, taking into consideration the forces which are exerted on the mold due to the pouring of green concrete and vibration. Now, tolerances. The molds have to be designed in such a way taking into consideration of suitable tolerances. Slopes of the mold walls. For easy demolding of the elements from the mold with fixed sides, the required slopes have to be maintained. Otherwise, there is a possibility of the elements getting stuck up with the mold at the time of demolding and it will spoil the concrete. Next process is accelerated hardening. In most of the precast factories, it is economical to use fast curing methods or artificial curing methods, which in turn will allow the elements to be demolded much earlier, permitting early reuse of the forms. Any of the following methods may be adopted: by heating the aggregates and water before mixing the concrete, by steam curing, by steam injection during mixing of concrete, heated air method, hot water method and electrical method. After the accelerated hardening of the above products by any of these above accepted methods, the element shall be cured further by normal curing methods to attain full final strength. Curing. For any concrete component, curing is an important part. The curing of the prefabricated elements can be effected by the normal methods of curing, of sprinkling water and keeping the element moist. This can also be done in case of smaller elements by immersing them in a specially made water tank. In all these cases, the difference between the temperature of the concrete product and the outside temperature should not be more than 60 degrees Celsius for concretes up to M30 and 70 to 75 degrees Celsius for the concrete greater than M45. In the case of lightweight concrete, the differences in the temperature should not be more than 60 degrees Celsius. For concretes greater than M50, the temperature difference can go up to 75 degrees Celsius. Now, stacking during transportation and storage. The following points shall be kept in view during stacking. Care should be taken to ensure that the flat elements are stacked with right side up. For identification, the top surfaces should be clearly marked. Stacking should be done on a hard and suitable ground to avoid any sinking of support when the elements are stacked together. In case of horizontal stacking, the packing materials shall be at specified locations and shall be exactly one over the other to avoid cantilever stress in panels. The components should be packed in a uniform way to avoid any undue projection of elements in the stack, which normally is a source of accident. Curing of the prefabricated elements can be effected by normal methods of curing by sprinkled water and by keeping the elements moist. Next are handling arrangements. Lifting and handling positions shall be clearly defined, particularly where these sections are critical. Where necessary, special facilities such as bolt holes or projecting loops shall be provided in the units and full instructions supplied for handling. For the purpose of testing the bolts, hooks, bond strength shall be the criteria for embedded bolts and bearing strength for through bolts. For bond strength, pull-out test of concrete shall be carried out. For precast pre-stressed concrete members, the residual pre-stress at the edge of particular operation of handling and erection shall be considered in conjunction with any stress caused by the handling or erection of the member. The compressive stress thus computed shall not exceed 50% of the cube strength of the concrete at the time of handling and erection. The tensile stresses up to a limit of 50% above those specified in IS 456 shall be permissible. Identification and marking. All precast units shall bear an indelible identification, location and orientation mark as and where necessary. The date of manufacture should also be marked on these units. The identification markings on the drawing shall be the same as that indicated in the manufacturer's literature and shall be shown in a table on the setting schedule together with the length, type, size of the units, etc. so that at the time of construction all these units fall into place as per the drawing. Transport. Transport of precast elements from the factory to the site is of considerable importance, not only from the point of view of economy, but also from the point of view of design and efficient management. The transport of precast elements must be carried out with extreme care to avoid any jerk and distress in elements, and handled as far as possible in the same orientation as it is to be placed in the final position. Now, transportation can happen in two types. One is transport inside the factory. Now, all these precast elements molded inside the factory can be transported from one place to another, and this depends on the method of production selected for the manufacture. Transport from stacking yards inside the factory to the site of erection. The transport of precast concrete elements from the factory to the site of erection should be planned in such a way so as to be in conformity with the traffic rules and regulations as stipulated by the authorities. The size of the elements is often restricted by the availability of suitable transport equipment such as tractor cum trailers to suit the load and dimensions of the member, in addition to the opening dimensions under the bridges and load carrying capacity while transporting the elements over the bridges. So, it is an important point, because if we have a massive precast concrete element, we cannot transport it, it is of no use. So, we have to check the heights available under the bridges of its way to site. We have to check the dimensions available for the transport vehicle, trailers, trucks, etc. So, it is a very important point that the precast elements have to be transported from the factory to the site where it has to be erected. So, while transporting elements in various systems, care should be taken to avoid excessive cantilever actions and desired supports are maintained. Before loading the elements and transporting media, care shall be taken to ensure that the base packing and supporting elements are located at specified positions only. Subsequent packing shall be kept strictly one over the other. Now, erection of these precast elements. In the erection of precast elements, all the items of work shall be included. The first point is slinging of the precast elements. The second point is tying up of erection ropes connecting to the erection hooks. The third point is cleaning of the elements and the site of erection. The fourth point, the cleaning of the steel inserts before incorporation in the joints, lifting up of the elements, setting them down to the correct envisaged position as per the drawing. The fifth point is adjustment to get the stipulated level, line and plumb. The sixth point is welding of cleats. The seventh point is changing of erection tackles. Next is putting up and removing the necessary scaffolding or supports, and then welding of the inserts, laying of reinforcements in joints and grouting the joints. Last but not the least, finishing the joints to bring the whole work to a workmanlike finished product. The equipments used in the precast industry or construction may be classified into the following categories. Machinery required for quarrying of coarse and fine aggregates. Next, conveying equipment such as belt conveyors, chain conveyors, screw conveyors, bucket elevators, hosts, etc. Then concrete mixing machines, then concrete vibrating machines, then erection equipment such as cranes, derricks, hoists, chain pulley blocks, etc. Then transport machinery such as tractor cum trailers, dumpers, lorries, locomotives, motorboats, and rarely even helicopters for airlifting them. Workshop machinery for making and repairing steel and timber molds, bar straightening, bar bending and welding machines to make reinforcement cages, minor tools and tackles such as wheelbarrows, concrete buckets, etc. Then steam generation plant for accelerated curing. In addition to all these, pumps and soil compacting machinery are required to the building site for execution of civil engineering projects involving prefabricated components. Each of the above groups may further be classified into various categories of machines and further to various other types depending on the source of power and capacity. Mechanization of the construction and erection process. These various processes can be mechanized as in any other industry for attaining the advantages of mass production of identical elements, which in turn will increase the productivity and reduce the cost of production in the long run, and at the same time guarantee a quality-wise perfect without error end product. On the basis of the degree of mechanization used, the various precasting factories can be divided into three categories. simple mechanization, partial mechanization, complex mechanization leading to automation. In simple mechanization, simple mechanically operated elements are used to reduce manual labor and increase the speed. In partial mechanization, the manual work is more or less eliminated in the part of the process. For example, the batching plant for mixing concretes, hoist to lift the materials to a great height, and bagger and bulldozer to do earthwork comes under this category. In the case of complex mechanization that leads to automation, a number of processes leading to end products are all mechanized to a large extent, without or with little manual or human element involved. This type of mechanization reduces manual work to the absolute minimum and guarantees mass production at very fast rate. For equipments, we have to refer relevant Indian standards for production of concrete. Let's move on to the second part of the lecture. In this part, we will talk about the safety principles involved that we should take care while dismantling a structure. Now, demolition is the dismantling, razing, destroying or wrecking of any building or structure or any part thereof. Now, demolition work involves many of the hazards associated with construction. However, demolition involves additional hazards due to unknown factors which makes demolition work very dangerous. These may include changes from the structure's design introduced during construction, approved or unapproved modifications that altered the original design, materials hidden within the structural members such as lead, asbestos, silica and other chemicals, or heavy metals which require specialized handling. It may also happen that radioactive materials may be inside a structure and we do not know. So, when we demolish that, we have to take specialized precautions. Unknown strengths or weaknesses of construction materials such as post-tension concrete, and hazards created by the demolition methods used. So, in a broad way, while dismantling a structure, it is very important to follow the safety procedures. It is because when we are making a new structure, we know what we are doing, we know what we are creating. But when a structure already exists, it's very difficult to determine how that particular structure is made up of. So, it requires a lot of planning, a proper methodology and proper inspection to achieve a proper dismantling without any accidents. To combat these, everyone at a demolition work site must be fully aware of the hazards they may encounter and the safety precautions they must take to protect themselves and their employees. The important principle is to plan ahead to get the job done safely. An engineering survey must be completed by a competent person before any demolition work takes place at site. This should include the condition of the structure and the possibility of an unplanned collapse. The structural engineer, a competent authority should cross-check that the structure is safe and sound to be demolished and the structure will not collapse unplanned. Locating, securing or relocating any nearby utilities. We should check and ensure that there are no mass congregation areas like bus stops, like hospitals, like schools, etc., so that the dismantling do not cause any damage to these institutions. Fire prevention and evacuation plan, first aid and emergency medical services, an assessment of health hazards completed before any demolition work takes place. So, we need to know what we are dismantling. In that regards, we have to know that what that particular material made up of, because every material, for example, asbestos, when asbestos it is demolished, it can cause a grave injury to our lungs, and also it is important to provide the right protection and equipment. The employer who is dismantling who is overseeing the dismantling process, he should provide the right equipment. In demolition operations, the protections may include eye, face, head, hand, foot protection, respiratory protection, hearing protection, personal fall arrest systems, other protective clothing, for example, cutting or welding operations. Now, what we learned? We learned about precast concrete elements and how they are formed, how they are transported and erected during construction. We learnt about the safety principles which should be involved in dismantling activity involved in construction. The typical questions can be: how are precast concrete elements formed? Explain various stages involved from manufacturing to erection of precast concrete elements. Write a brief note about safety principles to be adhered during demolition activities of construction. Thank you.